So picture this. Astronomers are looking up at the sky and they spot something just incredible. A visitor blazing through our solar system at over 58 kilometers a second, coming from that vast, dark emptiness between the stars. It's only the third interstellar object we have ever seen, and its name is 3I/Atlas.
And right away, the debate just exploded. Most scientists looked at it and saw a comet. A weird one, sure, coming from some other star system, but a comet nonetheless. But a few people, when they looked a little closer, they saw things that didn't quite add up. And that sparked this huge question. Are we looking at a simple chunk of ice and rock, or could this be something else?
Okay, let's get into it.
What you're seeing here is the object's path through our system. See that wide-open curve? That's what astronomers call a hyperbolic trajectory. And what that really means is that 3I/Atlas isn't trapped by our sun's gravity. It came from deep space, it's making just one pass through our neighborhood, and then it's heading right back out, never to return. A true one-time visitor.
So why all the fuss? Why this huge debate? Well, it all kicks off with a list of really strange characteristics, a whole series of clues that just seemed way too coincidental to be random. And this, right here, is where our cosmic detective story really begins.
The chief detective leading the charge in this case is a Harvard physicist named Avi Loeb. He and his team started putting together a list of all these oddities, and their argument was pretty simple. Any one of these could be a fluke, sure, but when you put them all together, well, they started to paint a very, very strange picture.
And this is where the coincidences really start to stack up. First off, its orbit. It's moving backward, against the flow of all the planets, but its path is almost perfectly flat, on the same plane as them. What are the odds of that? About 0.2%. Then you've got the flybys. Its trajectory just happens to take it unusually close to Venus, Mars, and Jupiter. The probability of that happening by chance is a minuscule 0.005%. Oh, and it also just happens to make its closest approach to the sun at the exact moment it's completely hidden from our view here on Earth. But this image from the Hubble telescope, this reveals the strangest clue of them all. You see that faint, narrow little line? That's a jet, and it's pointing towards the sun. Now, that is just bizarre. Comets' tails are made of gas and dust being pushed by solar wind, so they always point away from the sun. That's like Comets 101. A sunward-pointing anti-tail like this is incredibly rare and really, really hard to explain.
So here's the kicker. When you take all these geometric oddities, the flat orbit, the planetary flybys, the weird jet, and you multiply the probabilities of them all happening by pure chance, Avi Loeb calculates that the combined odds are 1 in 4 trillion. That is just an absolutely mind-boggling number. And that incredibly low probability is what Loeb and his collaborators to ask a pretty extraordinary question. What if these aren't random coincidences at all? What if these aren't bugs? What if they're features? And this idea gets some support when you look at the object's trajectory. These charts show something called delta V, which is basically just the change in velocity, or the amount of energy it would need to intercept our planets. And the main takeaway here is that the amount of energy is remarkably low. Its path is almost a perfect tour bus route through the solar system, making it incredibly efficient to visit and observe multiple planets with minimal effort. And from that perspective, suddenly all the puzzle pieces seem to snap into place. The close flybys? They're not chance, they're for reconnaissance. Hiding behind the sun when it's closest to it, that's not a coincidence. It's the perfect spot to fire an engine or make a course correction, completely hidden from our telescopes. And that bizarre sunward jet? Well, maybe it's not natural at all. Maybe it's technology, some kind of propulsion system, or maybe even a shield to protect a craft from the sun's radiation. But, as they say in science, extraordinary claims require extraordinary evidence. And the vast, vast majority of the scientific community lined up with a much simpler explanation, mounting a really powerful counter-argument. Penn State astronomer Jason Wright puts the consensus view, well, pretty bluntly. He says this isn't about scientists just being closed-minded. The argument is that it's about looking at all the evidence, not just picking out the weird parts. And really, that's the heart of the counter-argument. For every one of these strange anomalies, there are dozens of other observations where 3I/Atlas acts exactly, precisely like a comet. It grew a coma, that fuzzy atmosphere of gas and dust. It developed a tail. Its brightness changed as it got closer to the sun. You know the old saying, if it walks like a duck and quacks like a duck, it's probably a duck. And we've brought out the big guns to check. On the left, you see data from the James Webb Space Telescope, which found that its coma is full of carbon dioxide gas. And on the right, the European Space Agency's XMM Newton telescope saw the object literally glowing in X-rays. Both of these are classic textbook signs of a comet interacting with sunlight and the solar wind.
Okay, so we have these two competing narratives, the alien probe versus the natural comet. But what about that smoking gun? That sunward jet that seems so impossible? Well, the answer finally arrived, and you won't believe where it came from. Now, to get this, we need a quick primer on something called the Hazer model. Don't worry, it's pretty simple. It's basically just a model physicists use to describe that cloud of gas and dust around a comet. It lays out how ice grains get shot off the nucleus, travel outwards, and then eventually just evaporate or sublimate in the sunlight. And here it is, the big reveal. On the left, there's Hubble's image of that mysterious jet. And on the right, that's a physical model showing exactly how that same jet could form completely naturally. And what's truly amazing, the scientific paper that explained this natural mechanism was co-authored by Avi Loeb himself. So here's how it works. The side of the comet facing the sun gets absolutely blasted with intense energy. This makes gas shoot off more violently, and that can lift up bigger, heavier ice grains. Now, these bigger grains take a lot longer to evaporate, so they travel much farther before they disappear, and what that does is create this natural, elongated snow line of ice grains that points straight back towards the sun. It looks exactly like a focused jet, but it's just pure comet physics.
So it seems like the mystery of the jet is solved, but this whole debate around 3I/Atlas leaves us with some much bigger questions. Questions that Loeb himself asked at the end of his essay. Even if it is a comet, it's a deeply strange one from another star. The whole episode really challenges us to ask, what is 3I/Atlas really? And maybe more importantly, why shouldn't we be more curious when the universe sends us something that defies an easy explanation? It's definitely a question worth pondering.